Tangent. Today we shall discuss the affinity law. So this is used to reconfigure the performance of a pump from one speed to another as it defines. And this law states that for similar conditions of flow, example, substantially same efficiency, the capacity will vary directly with the ratio of speed and or impeller diameter and the head with the square of this ratio at the point of best efficiency. Now, meron tayong formulas for reconfiguring the pump performance. Now, for diameter change only, so it means, now, mapapansin ninyo, we notice this, diameter change only. So, it means, ang diameter ng impeller ng pump yung nagbabago. So, we have your D1s as was discussed yung impeller mismo, no? So, that will be your... So, D1 stands for initial diameter and D2, that will be yung final diameter. Then, mapansin niyo dito, we have the volume flow rate. So, this is the volume flow rate 2. And this is the initial or yung before na flow rate. So, we have the ratio. So, pag magbago yung diameter ng pumps natin, if you're going to change that one, so, yung volume flow rate niya is being affected. Okay? Then, in terms of the head or the total dynamic head, so we have yung final head or yung head 2 is equal now to the head 1, which is yung initial head, total TDH niya or total dynamic head, times the diameter 2, which is yung final diameter, which is the changes, divided by D1, so that it will be raised to squared. Okay? So, if you're going to change the diameter from smaller to bigger, so you will attain a greater head. No? Yung value ng total dynamic head natin also changes. Now, in terms of brake horsepower, so we have brake horsepower, that will be yung initial times D2 or the final diameter divided by the initial diameter raised to cube. So, it affects also. So, if you have this type of, for example, sa trabaho, if you will going to change the impeller, usually, mahirap na i-change yung impeller because yung bullet casing niya o yung casing ng pump will be greatly affected. But you can lower the size. So, if you were trying to increase, hindi ka nakapag-increase because kung mag-i-increase ka man ng diameter ng pipe, ng pump, so yung bullet casing niya will be affected. So, usually, pwede ka pang mag-trim ng diameter, which is decreasing the diameter from D1 to D2, so decreasing. So, it will be corresponding to lower brake horsepower and lower total dynamic head and also lower volume rate. Now, let's go to speed change only. So, it means speed change only is yung RPM ng electric motor that's being produced, no? Now, from final to initial, we have the ratio from initial RPM, final RPM divided by the initial RPM. So, from here, we have, if you're going to increase, no, the speed change. So, pansinin nyo, yung equation ito, if you're going to increase the volume flow rate, the RPM, we have a drastic increase also in volume flow rate. And the same also yung total dynamic head natin since it is squared, no? So, the same also yung total dynamic head ng pump natin will also increase. And the same also yung brake horsepower niya increases also yung consumption of electricity. Now, ang magandang application nito if you are trying to, let's say, boosted system, no? So, when we say boosted system or For example, yung water district system, no? Usually, you have a stationary pump, no? So, usually, yung stationary pump natin, no? For example, if we have a pump dito, okay? Now, if you were trying to, dumagdag ka ng mga lengths, you go into supplies, dinugtungan mo pa yan, and so on, and so on. So, you increasing yung, nag-i-increase yung head mo, and also nag-i-increase din yung volume flow rate mo. Now, yung pump natin, rather than, if this is our pump, and this is connected to an electric motor, okay? Now, rather than bumili ka ng isang set, which is usually napakamahal, compare if you're going to buy just a new electric motor. So, buying a new electric motor, increasing its RPM, that you, by means of computing, that will suffice the requirement ng system mo. So, makakatipid ka in terms of buying new sets of pump. So, usually, bibili mo lang ang electric motor. So, then, ikokouple mo dito, mag-adjust ka lang siguro ng pinapatungan niya yung tawag dito, concrete pad, and also yung base supporting plate ng pump and electric motor for mounting, and also yung balancing ng yung balancing ng connections of shafting. So, yun lang. Then you can save money from doon. Okay? So that is one factor if you want to maximize the pag nasa planta kayo nagtatrabaho. Okay, so this is one way, no, pag tatanungin kayo ng mga senior plant engineer na yan, do you have idea to answer yung papaano ninyo gagawin? So that's why napakaganda if you know this, if you will alam ninyo ito, and huwag nyo kakalimutan in practice pag tinanong kayo, you have idea. Now let's go to diameter and speed change. So we change both diameter and speed. Now for the volume flow rate is also being affected, no? So initially we have this ratio D2 D1 times N2 N2 1. So if you were going to increase the value from divided by the initial value, apektado pa rin yung volume flow rate. And the same also yung head natin. So we have H2 is equal to H1, then multiply by diameter 2 divided by diameter 1 times the RPM2, which is yung final, then yung initial RPM, then close parenthesis, raised to square. So from here, mapapansin nyo pa lang, from this equation, we can see the abrupt changes of your head. Now for the brake horsepower, so that will be the initial. So that will be also the same ng ginamit doon. Right? Then this time, it is being raised to square. It is being raised to cube. So from here, we multiply this one, we can have the abrupt changes. So if we're going to change the diameter and the speed at the same time, so we can attain a greater brake horsepower. Okay. But fully understand yung dinidiscuss ko kanina. So we have here a sample problem. So we have here a pump operating. So you have your N1. I'm gonna write it here. So that will be, we have the value of 3,550. That will be your RPM. Then has a performance as shown in the solid line. So we have here percent efficiency. We have here yung y-axis mo, which is in head in feet. And you have your capacity, which is, this one is your TDH. So ito yung TDH or total dynamic head at this side. And we have here your capacity, which is yung volume flow rate. Now, calculate the performance of the pump if the operating speed is increased to N2 is increased to 4,000 RPM. Okay? RPM. Then, so paano binabasa ba ito yung chart na ito? So this is yung tinatawag natin na, so this is called the pump characteristic curve. So this usually dito nakikita yung mga properties ng pump, no? So mapapansin nyo, we have here the percent efficiency saan siya tumatakbo with this line. Then with the corresponding brake horsepower, BHP, we have your RPM, no? So this is yung sinasabi niya, no? 4,000 RPM, dash line. Then the solid line, we have 3,500 RPM. Now, SPGR, that will be the specific gravity of the fluid. So, yung makita nyo, that is 1, means we are using water. So, the specific gravity of water, di nagbabago yan. It will be equal to always 1. Now, we have also here the dash line dito. So, we have here 9 inches. So, this is the diameter at the 4,000 RPM. And we have here the diameter 9 inches at 3,500 RPM. So, we have yung volume flow rate yan. So, mapapansin ninyo, the volume flow rate, 350, this is total dynamic head, which is 350 feet in H2O, increases to 450 feet ng total dynamic head niya. So, in-employ niya from 3,550 RPM to 4,000 RPM. Then, mapapansin nyo, as you go along, we have the volume flow rate nung ang kaya niyang i-produce corresponding doon sa head na kanyang ring i-produce at that portion. So, for example, we have 500 GPM with the corresponding 400 feet of H2O. Okay, so this is feet of H2O, feet of water. Now, kung babalikan natin yung formulas for reconfiguring the pump performance. So, we change the RPM. So, speed change only. Okay, so you notice here, so we have this ratio, corresponding ratios, no? So, we'll try to use this one to compute yung pagbabago ng flow rate, head, and brake horsepower. Okay. So, let's try to use yung correction factor. So, initially, we have your correction factor ratio nito, no? To multiply the volume flow rate, and another one para nito, tsaka nito. So, using that one, we have your F for correction factor, that will be your N. So this will be your N2 divide your N1. So that is equal to 4,000 RPM, no? Then it will be divided by nung value ng initial value natin, which is the 3,550 RPM. So, using your calculator, we have the value of 1.13. Okay. Then next, let's go to another correction factor, which is, let's say this is your F squared. So, next, we have this one, another ratio, which is squared. Yung value niya lang. No? So, that will be N1, N2 over your N1. So, this is raised to squared. Okay. So, we have your 4,000 RPM. Then, it will be divided by yung initial natin, which is 3,550 RPM. Now, this time, I'm going to square this one. Okay. Then, using your calculator, we have the value of 1.27. Sorry, I'm gonna change this one para kasi siyang 8. So, I'm gonna change this one to 27. Now, next, we have your F3. Okay. Take note, balikan natin yung equation kanina. So, we have N3 for this one. Then, we shall substitute it here. So, we have your N2 divided by your N1 raised to cube. Okay. Then we have 4,000 RPM. Then it will be divided by, again, 3,550 RPM. Now this is raised to cube. Then using our calculator, we have 1.43. So we have now yung correction factor. Now we're going to multiply it to calculate the condition at the 4,000 RPM. So at 4,000 RPM, okay, so we have your volume flow rate 2, that will be Q sub 1, no, initial volume flow rate, times the 1.13. 1.13, this is 1.14, 1.13. Now, we're going to substitute, for example, if the pump has a volume flow rate of 100 GPM. So, subtry natin yan, no? If we're going to have a volume flow rate of 100 GPM, I'm going to multiply it by 1.13. So, we have the volume flow rate of, we have a corresponding volume flow rate of 113 GPM. So, notice 100 and then when have 113 at the 4,000 RPM. Then, for the head naman, if we have yung head, so that will be the value of your head. So, for example, dito, we have your head, which is equivalent to 350, no? Yung RPM do, 3,550. Head niya is 350 feet. So, I'm going to multiply it 350 feet of H2O. This is feet of H2O. Multiply by 1.27. So, for head. Okay. So, we have the value of 444.5. So, this is feet of H2O. I'm gonna write that one. So, this is also feet of H2O. Now, kung titignan natin dito sa pump characteristic curve, so that is 444. So, this is somewhere dito. So, this is 400 and 450 at 100. So, magpo-flow siya somewhere here. Or 100, no? 100 at the corresponding 113. And it is somewhere here. Okay? So, you notice the total dynamic head changes abruptly. Then, for our brake horsepower, BHP, so that will be BHP2. This is head 2. So, you have your BHP1 multiplied by the value of 1.43. Okay, so looking at the pump characteristic curve,